Question 1. Solve x over 3 plus 3x over 4 equals 2. We want to multiply every term by a magic number, or what I call a magic number. And this number in this case, we'd want it to relate to 3 and 4 together. We want to pick a number that 3 and 4 both divide into. So the perfect way to get that is to do 3 times 4 and get 12, because then we know that both 3 and 4 do go into that number. So we're going to multiply every term by 12. So I put brackets around each term, and I'm going to multiply every term by 12 and see how that helps. Now we can divide on in that first term, x over 3, when that gets multiplied by 12, we can say 3 goes into the bottom once, and 3 divides into 12 4 times. Now when that 4 is the outcome there, I'm going to multiply that 4 by whatever is on the top of the fraction, in this case x. So I'm going to go, in my mind, 4 times x, and get 4x as the outcome for that first term there. In the second term, we're also multiplying by 12, and we'll say to ourselves 4 goes into the bottom once, and 4 goes into 12 3 times. So when we find a number that goes into the bottom and the top, we just divide them into each. That resulting 3, that when 4 went into 12 3 times, that then multiplies by the top, which in this case is 3x. So 3 times 3x makes 9x. On the right hand side of the equal sign, there's nothing on the bottom, there's no fraction there as such, and so we just do 12 times 2, making 24 for the right hand side. Okay, left hand side of what's resulting there, we've got a 4x and a 9x, so we can add those like terms together and get a total of 13x. And we have 24 on the right hand side. So we want x on its own, so we're going to divide both of those terms by 13 in the interests of getting x on its own. 13 divided by 13 just goes once, so that leaves us with x on the left hand side, and we can write the result on the right hand side as just 24 over 13. When a number is dividing by another number, we can write it in fraction form like that. So final answer for question 1, x equals 24 over 13. Question 2. Solve 4x plus 5 all over 7 equals 3. Okay, now we usually move plus or minus numbers around, trying to get the letter on its own, or the x on its own in this case. We usually move the plus or minus numbers before we move any multiply or divide type numbers. But because of that long fraction line, we must move the bottom number first. We're going to move the 7 first before we have a look at moving the 5 or the 4. So we say to ourselves, how do we move a 7 that's dividing? We do the opposite to both sides. So we're going to multiply by 7 on the left hand side and on the right hand side of the equation. Now a dividing by 7 and a multiplying by 7 kind of cancels each other out. So on the left hand side, that leaves us with 4x plus 5. On the right hand side, we just do 3 times 7 makes 21. And then we can just solve it like a normal two-step equation here. We'd like to move the 5 next. By doing the opposite to both sides, we plus 5, instead of plussing 5, we'll minus 5 both sides there. The plus 5 and the minus 5 will cancel each other out, leaving us with 4x on the left hand side, and 21 minus 5 will give us 16. And to get the x on its own, the 4 is multiplying by the x, so we'll do the opposite to both sides. We'll divide both sides by 4, leaving us on the left hand side with x, and the right hand side with 4. So final solution there, x equals 4. Question 3. Solve x over 3 is less than 2. Now, the rules for solving inequalities, which is what we're doing here. We solve inequations by using the same methods as solving equations with one exception. If you multiply or divide by a negative, the direction of the inequality sign changes. So we'll watch out for seeing in our solution if we're ever multiplying or dividing by a negative number. If we are, we'll switch the arrow direction around. So to get x on its own here, the 3 is dividing into the x, so we need to do the opposite to both sides. We'll need to multiply both sides by 3. The divide by 3 and the multiply by 3 kind of cancel out, leaving us with x on the left hand side is less than 6 because we've got 2 times 3 on the right hand side. Now we didn't multiply or divide by a negative number at any stage, so the arrow or the inequality still keeps pointing to the left. But we'll watch out for that in future questions. Question 4. Solve. 3a plus 4 is less than 5. We solve inequations using the same methods as solving equations, except watch out for seeing if we multiply or divide by a negative, because if we have, the direction of the inequality sign changes. Okay, we want to get the a on its own, so we're going to move the 4 first. The opposite of a plus 4 is a minus 4, so we're going to minus 4 both sides. A plus 4 and a minus 4 will cancel out on the left hand side, leaving us with 3a. And 5 minus 4, just on your number line, or just in your brain there, leaves us with less than 1 for the right hand side. And to get a on its own, we need to cancel out a 3 that's multiplying, so we're going to divide by 3 both sides, leaving us with a on the left hand side and less than 1/3. We can just write 1 divided by 3 in fraction form there. Now at no stage, once again, did we multiply or divide by a negative number, so the arrow didn't change. The inequality sign is still going to the left. Question 5. This time we have solve. 8 minus 2b is greater than 7. We solve inequations using the same method as solving equations, except if we multiply or divide by a negative value, the direction of the inequality sign changes. We'll have to watch very carefully in this one, no hints. Okay, we want to move the 8 in the interests of getting the b on its own eventually. That's a positive 8, so it's actually like it's plussing 8 there. So we're going to do the opposite to both sides. The opposite of plussing 8 is minusing 8 both sides. Now very carefully, that minus in front of the 2b belongs to the 2b, so he needs to survive there. So a plus 8 and a minus 8 will cancel out, but we don't need to touch that minus that belongs to the 2b. So on the left hand side we'll have a minus 2b still there, after the 8's are gone. Greater than, and we have 7 minus 8. We're taking away one more than we've got there. So on the number line or on your calculator you'll get a minus 1 for that right hand side. Okay, now what we've got on the left hand side at the moment is a minus 2 that's multiplying by the b. Now the opposite of multiplying by a minus 2 is dividing by a minus 2. It's a bit tricky, you've got to be a bit careful with that. So we're trying to undo a multiply there, not really a minus. So a minus 2 that's multiplying, dividing by minus 2, that'll cancel out nicely, leaving us with b. And we'll notice something special happens next. The inequality sign changes direction because look at what we did there. We divided by a negative value, and we said that if we're multiplying or dividing by a negative value, the inequality sign changes direction. On the right hand side we have a minus 1 divided by a minus 2. We can just write the 1 divided by 2 in fraction form there, and a minus divided by a minus, I think you'll probably realise, makes a positive answer there. You could check on your calculator. But we end up with b is less than a half. Question 6. Solve 3 outside of 2 minus 3m is less than 24. We'll expand the brackets first, then we'll try and solve the inequation normally. So to expand the brackets, just before we do, we'll remember that the overall principle here is we solve inequations the same way as we solve equations, except if we're multiplying or dividing by a negative. Okay, to expand that, we get 3 times 2 is 6, and 3 times minus 3m is minus 9m. So that's our left-hand side expanded, and that's still less than 24. Now we'll solve what's left there. There's a 6 there, or a positive 6, a bit like a plus 6 that we need to get rid of here on the left-hand side in the interest of getting m on its own eventually. So the opposite of a plus 6 is a minus 6. We're going to minus 6 both sides. A bit like in the last question, that minus that belongs to the 9m shouldn't be changing here. We shouldn't be really affecting that. So a plus 6 and a minus 6 cancels out, leaving us with minus 9m on the left-hand side is less than 24 minus 6 is 18. Okay, that minus 9 is multiplying by the m, so we'll need to divide by a minus 9 to kind of cancel it out, leaving m on its own. So if we divide by minus 9, the m ends up being on its own on the left-hand side, and because we're dividing by a minus number, guess what? That inequality sign changes direction. So we'll now have m is greater than, and 18 divided by minus 9, a plus divided by a minus is a minus answer, and 9 goes into 18 twice. So we'll have m is greater than minus 2 for our final answer. There's a fair bit going on in these questions, so we have to be a little bit careful. Question 7. Solve 6x minus 1 is greater than or equal to 2x plus 9. To solve an equation with letters on both sides, we'll combine the letter terms by moving the smaller letter term first. In my experience, that makes these questions go a whole lot smoother if you move the smaller letter term first to combine the letter terms together. So in this case, we're going to move that 2x from the right hand side, and the opposite of a positive 2x there is minusing 2x. So on the right hand side, that 2x and the minus 2x will cancel each other out, but we'll process that left hand side. 6x minus 2x will leave us with 4x on the left hand side. Minus 1's still there, still got the greater than or equal to sign, and because the 2x and the minus 2x cancelled out, we're just left with 9 on the right hand side. Okay, we've then just got a normal one from here. We want to move the minus 1 by plussing 1 both sides, leaving us with 4x on the left hand side because the minus 1 and the plus 1 cancelled out. We've got a greater than or equal to sign, and 9 plus 1 is 10. We're then trying to move to get x on its own, move the 4 that's multiplying, so we're going to divide by 4. We're going to do the opposite of both sides there. So on the left hand side, we're left with x is greater than or equal to 5 over 2. Now we got 5 over 2, I didn't show it in 2 steps here, but we've got 10 divided by 4. We could write that or think of it as 10 over 4, and if we type that into our calculator and pressed equals, that would give us 5 over 2 as what we'd call an equivalent fraction. So to simplify that down, 10 divided by 4 ends up being 5 over 2 as our final answer there. X is greater than or equal to 5 over 2. Question 8. Show by graphing on the number line x is less than or equal to 3. Okay, on these ones, we've got greater than or equal to signs. They have a closed circle and they point to the right-hand side. And less than or equal to signs, like we've got in this question, have a closed circle and they point to the left. The arrow points to the left. Now you'll notice the arrow in the inequation sign, the less than or equal to sign, points to the left, and so will our final arrow for our answer. And I've got a tricky way of remembering whether we have a closed circle or an open circle for these graphs on the number line. I like to think of that extra line underneath the less than sign to make it a less than or equal to sign as providing a little bit of extra ink to fill in the open circle to make it a closed circle. So anytime you see a greater than or equal to sign or a less than or equal to sign, just think to yourself in a fun way that you've got extra ink to fill in the circle. And the arrows point the same direction as the inequality sign, if the X is written first, of course. So here, we're going to put a dot on the 3, and it's a closed dot because it's a less than or equal to sign, and the arrow goes to the left, just like the arrow, if you imagine that less than or equal to inequation symbol, that's what kind of points to the left as well. So I hope that helps, that sort of thinking. Okay, question 9. Use the substitution method to solve this pair of simultaneous equations. We have 2x plus y equals 3 and y equals x plus 6. Alrighty, let's get to it. Now if you notice that second equation, it has y equals x plus 6. I'm going to put a bracket around it, and you notice I put it in red there to show that y equals x plus 6 because I'm going to replace the y in the first equation there with x plus 6. I'll show you here. So instead of 2x plus y equals 3, which the first equation was, I'm going to replace the y with the x plus 6. So you can see that the 2x is the same, but I've replaced the y with x plus 6. Now why did I do that? That's because the other equation, the second equation of my originals, told me that y can equal x plus 6. So why did I do that? Well, what results now is that I've got a 2x plus an x plus a 6 equals 3. They're all just talking x language. And so we've kind of merged the equations together to get something that we can now solve. So we're going to collect like terms here. We've got a 2x and a 1x, making a 3x, and a 6 equals 3. So I've just added those x terms together really. And then we can solve that equation to try and get x on its own. So we're going to minus 6 both sides. So when we minus 6 from the left hand side, we're left with 3x. When we minus 6 from the 3 on the right hand side, we get minus 3. Okay, we want to divide both sides by 3. I didn't do it, I did it sort of invisibly here. But divide both sides by 3, we'll get x left on its own. And dividing the right hand side, minus 3, if we divide that by 3, we'll get minus 1. Okay, so we found one value here, the x value. We need to substitute that back in to one of the original equations to find our y value. We've got an x value so far. Let's sub that back into either of the equations there, the original equations, to find out what y is. Okay, so if we take the second equation, because it's a bit simpler, y equals x plus 6, I've just written it out on the top right hand corner there. I'm going to put a minus 1 wherever the x is in that equation and solve for y. So I've got y, instead of the x, I've put a minus 1 because we're halfway through the question, or more than halfway through, and we've found that x equals minus 1 so far. Minus 1 plus 6 is 5. So overall, we've got our solution to the pair of simultaneous equations as x equals minus 1 and y equals 5. Quite tricky. There's a video on simultaneous equations that you should watch from my website or my YouTube channel. Question 10. Use the elimination method to solve this pair of simultaneous equations. We have 4m plus n equals 10 and 3m minus n equals 4. Alrighty, First thing we've got to decide is whether we want to add between the two equations or subtract between the two equations. I'm going to focus on the n terms that are in the middle of each here. We've got a plus n in the first equation and a minus n in the second equation. Now I'll decide to either plus between the two equations or minus between the two equations so that those n terms cancel each other out. Now if I put a minus in between the two equations, at some stage we're going to be doing plus n minus between the equations, a minus n. The two minuses will make a plus, and I'm here to tell you that that wouldn't make the n's cancel out properly. It's a bit tricky, but watch the videos on my website or my YouTube channel to find out more. But I'm going to add between the two equations here because that's the symbol that's going to help me cancel out the n's. So I'm going to put a plus there. Now let's take each set of terms that are kind of like terms in turn here. If we've got a plus between the equations, we're going to take 4m and plus 3m to it to make 7m. And then we're going to work on the n's. If I had plus n plus minus n, the plus minus that are together will end up being a minus. In the end we'd have a plus n minus n, which will cancel out, so we're going to not write the n's in for the next line, and the right hand side is just 10 plus 4. The more of these simultaneous equation questions you do, the better you'll get. No surprises there. Okay, we're left with 7m equals 14. We're going to get m on its own by dividing by 7 both sides invisibly. So we'll divide by 7 on the left hand side, cancel the 7 out, making an m. And the right hand side, if we divided by 7, would get 2. So m equals 2 so far. We need to take one of our two equations, maybe the first one, and substitute m equals 2. We're going to replace the m with a 2 and try and find out the value of n from that. So m equals 2, and this in the first equation that I've pushed off to the right, top right hand corner here, I'm going to replace the m with a 2, and 4 lots of 2 makes 8, plus n equals 10. So when I replace the m with a 2, I can just have an equation with numbers and the other letter, the n. To get rid of the 8, I'm going to minus 8 both sides, so we end up with n equals 2 as well. So final answer for this simultaneous equation is m equals 2 and n equals 2. Now I'm not pretending these are easy questions, there's a lot of steps there, but you'll get the hang of it once you get enough practice.